Welcome to the lecture on vibration and waves. I am Professor Dr. Rajiv Ganguly. In this section, we will be discussing fundamentally three things. The first one, we will try to understand what do we mean by a periodic motion. Then we will try to understand what is meant by oscillatory motion, and we will try to understand the difference between the two. And the third one is, what do we mean by simple harmonic motion, and more importantly, we will try to understand what is the fundamental difference between oscillatory motion and simple harmonic motion. So, we will compare them, we will not only find the differences, we will also find out their similarities as well. So, this is our basic task. These are the fundamental concepts without which we will not be in a position to understand the further aspects of the vibration and waves. Now, any periodic motion, there are primarily two important characteristics. This motion, number one, this motion repeats itself. This motion repeats itself. So, same type of motion occurs again and again. And the second important point is, this occurs after a definite time interval. This motion occurs after a definite time interval, and this definite time interval has got a name. It is called as the time period of motion, which is denoted by capital T. And this simple time, the unit of time period is of course second. So, what we find, the basic two characteristics, we are going point wise, basic two characteristics of this type of motion is that this motion is repetitive in nature, and this repetition occurs after a definite time interval. And one of the commonest example is, say our earth is moving round the sun in an elliptical orbit, all of us know. So, let this be the orbit of the earth round the sun, and we have the sun at one of the foci of the ellipse. So, let this be the sun, and this is the earth which is moving round the sun, and say this motion is occurring, and we know that earth returns to the same place after 365 and 1/4 days. 365 days in 1 year and 1/4 days. So, we get 1/4 for 4 years, we get a leap year. So, that becomes 366 days. So, what happens? Earth moves round the sun in an elliptical orbit again and again and returns to the same position after 365 and 1/4 days. So, two properties are obeyed. Number one is it repeats itself. So, same type of motion is going on millions of years together, and it occurs after a definite time interval. This time interval corresponds to 1 year on the earth. We celebrate New Year, year end, etc. This 1 year on the earth comes under this time period. So, it is smaller unit is second, bigger unit is of course year. So, these are the two fundamental characteristics of periodic motion, any kind of periodic motion. Now, the next thing that comes up when we try to discuss this vibration and waves is oscillatory motion, and these two are very closely linked terms. We sometimes read all of these things, but we are sometimes not in a position to understand what is the fine line of difference. Let me tell you all that oscillatory motion is a sub-type of periodic motion. Is a sub-type. What it means? Means that this motion will be repeating itself. It will be it repeats itself again and again. So, this property number 1 is valid here also. The second one, it occurs after a definite time interval. So, definite time interval is also there. So, it obeys that principle also. So, these two are in agreement with periodic motion. So, it is a type of periodic motion. Then there must be some special characteristics. There is one very special characteristics about oscillatory motion, that is the third point. We are putting a star mark, that is a third point just for our remembering. This third point means that there must be to and fro motion. There must be to and fro motion about a point. And this point is present where? This point is present along the path of the motion. That means oscillatory motion will preserve all the properties of periodic motion, but will have one very special point. It is to and fro motion about a point. Now the question is, what is to and fro motion? To and fro motion means, say if this is the entire path of motion, starts from A to B. So it goes from A to B, then returns from B to A. So if you consider any point at one part of the cycle, the body travels from left to right. At the other part of the cycle, body travels from right to left. Any point that we take along the length of the path, the body travels one from left to right, other one from right to left. So this is called as to and fro motion about a point. We can take a very simple example. Say we have a structure like this, where there is a spring that is connected to a support, and here we have an object. This is a rigid support fixed to the base, and we have one object here of mass m. So what we do? We pull it along the length. So the body might move up to here. So the body comes to here. The spring gets elongated, and the body moves like this. So any point along the length of the path, we take one point. We'll find at one point of time the body is moving from left to right, and other part is moving from right to left. So these type of motions that we encounter, they are called as oscillatory motions. So one thing we can definitely conclude, that oscillatory motion preserves all the properties of periodic motion. So this is a periodic motion also, but oscillatory motion also. But this motion is not an oscillatory motion. So we can say that all oscillatory motions are periodic motions, but all periodic motions are not oscillatory motions. So what is the conclusion from here? Conclusion from this section is that all oscillatory motions are periodic motions. But all periodic motions are not oscillatory motions. So this is a very important statement. This is the inference or the conclusion that we draw, that all oscillatory motions are periodic motions, but all periodic motions are not oscillatory motions. Like earth moving round the sun is a periodic motion, but it's not oscillatory motion. But in this case, the mass that is vibrating, that is an oscillatory motion, which is of course a periodic motion. Now after we have discussed these two, we enter into the simple harmonic motion. In simple harmonic motion, if we try to understand, this simple harmonic motion obeys the basic three principles of oscillatory motions. I am not repeating again. So number one, that means this repetitive nature is obeyed here. Number two, it occurs after a definite time interval, that is also obeyed. This to and fro motion about a point, that is also obeyed in simple harmonic motion. Then in simple harmonic motion, or very popularly it is called as SHM. What is the speciality? There is a speciality. The fourth point, I am writing it in a different color to emphasize. The fourth point differentiates between a simple harmonic motion and oscillatory motion. Simple harmonic motion, it is the simplest type of oscillatory motion is the simplest type of oscillatory motion that can be treated mathematically. So, it is an oscillatory motion of course, and if it is an oscillatory motion, it is also a periodic motion. So, but this is the simplest type. So, that makes the difference, and one of the examples is that a motion of a simple pendulum. A motion of a simple pendulum executes SHM. So, here from this discussion we understand what is periodic motion, what is oscillatory motion, and what is simple harmonic motion. And when I conclude this part of my lecture, I just want to say that a simple harmonic motion, just like this, all SHMs, all simple harmonic motions are oscillatory motions, but all oscillatory motions are not simple harmonic motions. In the next lecture, we shall concentrate on simple harmonic motion and we shall get into more details on this particular type of motion. Thank you.